Okay, so we are continuing with the same topic, the sequence representation. Sequence network representation, of transformer. So last time I have explained one case how we derive all the equations. So in this time, we are going to use the results only. Okay, I will repeat again. Zero sequence equivalent circuits of a three-phase transformer, they deserve, special attention, or we need to analyze them specially because various possible combinations are there. I have told you last time, primary and secondary windings have various combinations for star and delta, and they alter the zero sequence networks, and that we will see later. From the transformer theory, I have told you already that no current in the primary of the transformer will flow unless current will flow in the secondary if we neglect a small amount of magnetizing current. The primary current is determined by the secondary current, and they are related to each other by the turn ratio that we have seen. Again, with the magnetizing current neglected, that we can neglect the magnetizing current. Now, arrows in the diagram I have told you earlier also that they will show the possible paths for the flow of zero sequence currents. And absence of arrows in the transformer means that no such zero sequence current will flow. That cannot flow in the transformer. So general circuit I will be drawing. General circuit for any combination. So you see, if you have any type of combination, what you have to do. So general circuit we will draw. Let me draw the general circuit. Sorry, use this pen. You have to remember this circuit. Then only with the help of this circuit you can draw any. Okay, let me draw the circuit first. Okay, so this is the circuit. So this is your primary of the transformer, primary side, and this will be treated as a secondary side. So in general, we call it switch diagram for representation of transformer zero sequence network, or we also call it zero power bus. Zero power bus. Okay. So this switch we call 1, and this we call 2, this we call 1 dash, this we call 2 dash. So these 1 and 1 dash are primary switches. So I will write here the general circuit for any combination. The general circuit for any combination is given below in figure. So this is the figure and it is given here. Now let's move further. Here 1 and 1 dash are called primary switches. 1 and 1 dash, these are called what? Primary switches. 2 and 2 dash are called secondary switches. This here is a Z0 impedance, 0 seconds network, 0 seconds impedance. 1 and 2 are called series switches. While 1 dash and 2 dash are called shunt switches. So this is the combination in the circuit: primary switches, secondary switches, primary on the primary side, secondary on the second, series on the series circuit, and shunt on the shunt branches. These are the switches. Z0 is 0 sequence impedance. Z0 is 0 sequence impedance of the winding of the transformer and there are two series, as we have seen. There are two series and two shunt switches. Okay, one series and one shunt switch for both sides. One series and one shunt switch for both sides, for both the sides separately. So we have seen one shunt is on the primary side, one series is on the primary side, second shunt is on the secondary side, and second series on the secondary side. Okay. The next is series switch. When are series switches closed? These are very important things now. Series switches are closed of a particular side when the winding is star connected, neutral grounded. So you have to remember this. Series explanation I have given in previous, I have derived the equation. So now you have to remember it only. Series switches are closed of particular side. So when the series switches are closed of particular side, when winding is, and transformer winding is when winding is star connected, neutral grounded. Connected, neutral grounded. So that means whenever you are drawing a zero sequence network, so if you have any side the combination is this star connected, neutral grounded, then what will happen? Then series switches on the either side. If it is on the primary side, it will get closed. If it is on the secondary side, it will get closed. Second, about the shunt switches now. Shunt switches are closed. Shunt switches are closed if any side has delta connected winding. So any side having delta connected winding, the shunt switches automatically will get closed. Otherwise, they are left open. Otherwise, they are left open. So this is two things you have to remember. What we are talking about. First, series switches will get closed on the particular side if your winding is star connected, neutral grounded, and shunt switches will get closed on either side if your winding is delta connected. Otherwise, you have to keep them open. Okay. Now, for example, I have 6, 7 combinations. I will take one combination in detail, then we can think of the other combinations. Now, let us say star slash delta connected with star ungrounded we have. For example, I will take first, let us say transformer is windings of transformer on primary side is delta, secondary side is star. Delta star connected. Okay. Is delta star connected? So star ungrounded. Star is not grounded. Star ungrounded. Just like this, we don't have here ground, it is left open. Ungrounded. So what will happen here? Primary is delta connected. So what will happen? Delta, when the winding is delta connected, which type of switch will get closed? Shunt switches get closed. So I will write here when, since primary is delta connected, is delta connected. So the shunt switches of primary side is the shunt switch of primary side is closed. So now primary side is delta connected. So which switch will get closed? Shunt switch of the primary side is closed and series switch is left open. Left open. This is one. Now let us talk about the secondary now. Right here first. Now the secondary winding is star and ungrounded. The secondary is star ungrounded. This is ungrounded. We have seen this is not grounded. Star ungrounded. Therefore, which switch will? Therefore, the series switch is left because whenever the winding is star connected, neutral grounded, then only the series switches are closed. So nothing will happen. Therefore, what we can write, the series switch is left. Therefore, the series switch is left open. I'm writing in detail for first. Rest of all I will not write. And shunt such switches also left open. And shunt switch is also left open. So it's very clear. Shunt switch will be also left open. So let me draw it now. See, basic diagram is this you have to memorize. Now, what we have here, I'll draw first this one. Now, primary side is delta. Sorry. Primary side is delta. This is your delta. Now, secondary side is star. I'm drawing that winding on secondary side. Okay. Now, this is the transformer winding. Now, what should be our zero sequence now? How we have to draw it? Just a second. Let me complete this. Sorry. This is your primary winding. Okay, we'll be drawing the primary winding. So this is your star on the secondary side. Okay. Now remember this. Now what will happen here? See here, primary side is delta. So I will make here, I will use this pen. Primary side is delta. So whenever the winding is delta, which switch is closed? We know whenever the winding is delta. So, sorry, whenever the winding is delta, which switch is closed? Shunt switches are closed. So wherever, whichever side it is. Two things you have to remember. Series switches will close when the winding is star connected, neutral grounded, and shunt switches are closed when the winding is delta connected. So now we have a delta connected. So this switch will be left open. This will be left open. Now this will be closed like this. So primary winding is finished. Now on the secondary side, what we have? Secondary side, we have only star connected. There is no ground. Star connected. So both the switches will be left open. So what will be winding? This will go. This will remain. This will remain. That's all. So I will draw this here. I think you have. Yes, Mansha beta, have you understood?
Yes, sir.
Is it clear? So this will be open. This will be closed because shunt will be only. So on this side, both the switches will be open because winding is star connected. That's not grounded, that is ungrounded. So I will just take it because I have to use it. Okay. So now I will be drawing this. I'll be drawing this again with the black only. So now what will happen? Here, the first switch I will draw again, it complete, because I think you should know it clearly. So now this switch will be left open because series switch. Primary winding is what? Delta. And now here we also had a switch that I will draw just now. Just wait. I will draw first complete. so that you understand first, then you can easily draw others. Okay, I will draw it complete. Let me draw it. Okay, so here it is like this. Rest we can copy then afterwards. Now here, this is the series switch. This is the shunt switch. Okay, this is your winding, zero sequence impedance Z naught. Okay, just a second. Just a second. Oh, this is what is the original diagram we have. Okay. Now what's happening? Primary side. So primary side is delta connected. Series switch is open. So I have to connect this one because delta connected when the network when the winding is delta connected, shunt switches on either side, but it's on the primary side, so we have to close the primary shunt switch, number one. Now secondary winding is star connected, so I will write here again, this is combination, sorry, combination is like this: delta on primary side, star ungrounded on the secondary side. So now secondary side we have a star but ungrounded, so neither the series switch like this nor the shunt switch will be closed. So network, so winding, that's a zero sequence circuit. This is basically what this is, a zero sequence network. So zero sequence network will look like this. If I have to draw it in the simple, I will draw it like this. Sorry, I have to draw it like this. Okay, that's all. I don't need to draw other things. No need. This is your ground. Here it's open, no need. Here it's open, so no need. So it is enough for me to draw it here like this. So this is very clear that in this case, primary winding is delta and in secondary winding is star. So this is your zero sequence network. This is your zero sequence network. This is your zero sequence network for this combination. Now let's have a second combination where we have primary winding is star connected neutral grounded and secondary winding is star connected but ungrounded. So let me copy this now, or I will draw it here and I will draw on the table now, complete table, then other combination. Is there any questions? Anji beta. Roll number 53, Farhana. 53. Okay, roll number 8.
Yes, sir. Clear है.
Is it clear?
Yes, sir.
43, Naira.
जी सर क्लियर है.
Okay. If there is any question, you can raise your. What is this, Farhana? Roll number 53. Okay, let me draw this. Now, another combinations we have, let us say, we have symbols here. I'm drawing it intentionally. Then we have connection. And finally, we have zero sequence equivalent circuit. Okay. So let me draw first. Transformer symbol is like this. Okay. So this is primary side, this is secondary side. Primary side winding is star connected, neutral grounded. Secondary side it is star connected. So when we have to draw that, this will be like this. Okay. Okay, this is star connected. And let us copy this. Copy, paste. Okay. Now this is winding, sorry. These are the windings. Okay. Small I am making. Okay. Now this is neutral. Primary is neutral grounded. So this I am grounding. Secondary is not grounded. So again we'll be referring to this diagram. Okay. Here I can use like this. Okay. Now what is when we have a winding star connected neutral grounded, it is star connected neutral grounding, then series switches will close, but it's on the primary side. It's very important. So this switch is going to close here. Okay. Shunt switch will remain open. On the secondary side, we have star connected ungrounded. So both the windings are going to remain, open. So finally, how we are going to get? We are going to get winding like this. So we have here and that's our reference. No connection with the reference. This is Z0. You can draw it simply like this because only one of the primary series switch is closed, rest all are open. So diagram will be like this. You can always do it. Now next we have star connected neutral grounded and star connected neutral grounded. So I will copy this complete. And paste. Okay. Now what next we have star connected neutral grounded here. Primary as well as secondary is also star connected neutral grounded. Star connected neutral grounded. Mansha.
Yes, sir.
Okay, what will be the zero sequence equivalent network for this one? Primary is what?
Switch 1 would be closed and switch 2 would be closed as well.
Very nice. That means only the series switches will be closed. Shunt switches will remain as it is. So it can be simply drawn in a simple way. I can draw it. I'll draw it like this. This. No connection with the ground. So that's all. This is the, but here the difference is this switch and this switch is closed. This switch and this switch is closed. Here, this switch was open. Here, this is the only difference. Okay. So that's very good. Next, star connected, neutral grounded, and delta. Delta, I'm drawing bigger. Okay, let me copy this to okay, copy, paste. Okay, here. Okay, Now what I have here, star connected neutral ground on the primary side and delta on this side. Okay, this is delta. Star connected neutral ground. I will draw a delta here. Let me draw the delta. Okay. Delta is here. So this is your winding. Okay, delta is on this side. Okay, where is roll number 48? Diba.
Yes, sir.
Okay, tell me beta. Now winding, primary winding is star connected neutral grounded and secondary winding is delta. How we can draw the zero sequence network?
सर वन क्लोज होगा
Okay.
एक दो डैश टू डैश क्लोज होगा क्लोज
Very nice. So this will be closed because primary winding is star connected neutral grounded. Secondary shunt switch will be closed because winding is delta connected. Very nice. That means आपको समझ आया है. So I will be drawing that. So I will be drawing it like this. You have to understand it. इसमें कोई बड़ी मुश्किल बात नहीं है. Okay. Okay. Okay, this shunt switch is closed. I'm closing that. And after the shunt switch, we have Z naught. I am writing that. This is closed. For your information, I am writing this. Drawing this, otherwise it's not required. This is opened. This switch is opened. This is your Q side and this is your P side. Please write down this. This is P side, primary side. This is secondary side, P side and Q side. Okay. And also here we have a shunt switch on the secondary side that we are closing. So we are closing. Let me use this pen. So here closed. Here it's closed. Okay. Here it was also closed. So this is closed. This is closed. Primary shunt switch is open. Secondary series switch is open. Very nice. The next combination what I have. Next page will move. Okay, what do I have? Star and delta. So I will take this combination. I will copy this. And let me copy this. This is copy, paste. I'll paste it here. So what I have exactly? I have star and delta. That's all. No neutral grounded here. Okay. So this is your star, simple star, ungrounded, and this is your delta. This is your P side and this is your Q side. Okay, this is like this. You can draw this also. Okay. Okay. Roll number 8, Ishfaq.
Yes, sir.
Okay. Can you tell me how I will draw the zero? Primary is star connected, secondary is delta connected. What will happen? Shabash.
Sir, 1, 2 will be closed in case of sitar.
कैसे कैसे क्लोज हो गए? तो स्टार खाली अनग्राउंडेड है, क्या बोल रहे हो? क्लोज सीरीज स्विच क्लोज होते हैं तभी जब न्यूट्रल ग्राउंडेड होती है. ये न्यूट्रल ग्राउंडेड थोड़ी है. 1 2 will be open. Wrong. पहले wrong. What will happen to now 1 dash 2 dash?
1 dash 2 dash will be closed.
दोनों कैसे क्लोज हो गए? आपको समझ आ रहा है कुछ कि नहीं? पहले आप प्राइमरी साइड ले लो, प्राइमरी का सीरीज स्विच ओपन, प्राइमरी का शंट स्विच ओपन. क्यों? Because neither the winding is delta on the primary side, neither the winding is star connected neutral grounded. So both the switches will be open on the primary side. Secondary, series switch will be open. Why? Because the winding is not star connected neutral grounded. Shunt switch will be definitely closed. Why? Because the winding is delta connected. मुझे लगता है आपको समझ नहीं आया. इशफाक, आपको समझ नहीं आया है?
सर मैंने इससे पहले क्लास वाली नहीं थी वो.
तो प्रॉब्लम है, लेकिन अब मैं बता रहा हूँ रूल दो, आपको दो रूल याद रखने हैं. व्हाट्स द प्रॉब्लम? इसमें क्या प्रॉब्लम है? ओके, so now let me draw it. So now let me draw the complete again. यहाँ पे series switch open. Why? Winding is not star connected neutral grounding, winding is star connected ungrounded. This is not ungrounded, so open. Now this will be impedance. Now moving to the shunt switch. Shunt switch definitely will be open here, because why? Shunt switches are closed only when the winding is delta, but primary winding is not a delta connected winding. So shunt switch will be open, as well as the series switch will be open. Now moving to the secondary side. Secondary side, again series switch will be open. Why? Because the winding is not star connected neutral grounded, but definitely the secondary the shunt switch will be closed. Why? Because the winding is delta connected. So let me draw it. This is like this. Okay. So here is also switch. Here is a switch that will be closed. I will repeat it again. Why? Series switches will get only closed when the winding will be, इतना ही याद रखना, star connected neutral grounded. So neither primary winding is star connected neutral grounded. Primary switch आपका open रहेगा, series switch. Why? The winding is star connected ungrounded. तो series switch open रहा. अब आप secondary में चले जाइए, series switch. Secondary भी open रहेगा. Why? Because its winding is not star connected neutral grounded, so it will open. Now coming to the primary side about shunt switches. Shunt switch will be again open, because shunt switches are only closed when the winding is delta connected. Primary winding is not delta connected. Yes, secondary winding on the shunt switch on the secondary side will be closed. Why? Because the winding is now delta connected, so that will be only closed. So this is the zero sequence equivalent network for this one. So here it is Z0. So this is the way you have to draw it. Okay, next combination is delta delta. Let me copy this. I'll copy this here. Copy, paste here, and I need to copy this. Copy, paste. Oh. Just a second. Okay. copy it again. Okay, this side we don't need this. So on this side, primary side is P and secondary side is Q. Okay. Now what winding we have? We have both windings as delta delta. So primary side is delta, secondary side is delta. So let me copy this. Okay. So, okay, roll number. Where is another Diba? She is absent today. Roll number 43, Naira.
जी सर
Okay, what will happen, beta?
सर
Now,
डेल्टा डेल्टा सीरीज वाला सीरीज ओपन रहेंगे एंड शंट क्लोज हो जाएंगे
just a second.
Switch 1 open, 2 open.
Okay. Now, delta, so series switch on either side will remain open because winding will not be star connected, neutral grounded. But what will happen? Delta, both the switches on shunt switches will be closed.
Close.
यही कह रहे थे आप?
जी सर
Okay, that's fine. Okay, so this is, I will be closing this. ये एक मिनट. So now, again, I will repeat. Now, series switches will be open because windings on both sides are delta. Shunt switches both will be closed because the windings on both sides are delta. Shunt switches gets closed. So I will be closing them. So this switches I am closing. And in simple way, you can draw this diagram like this. How you can draw it? You can draw it like this, simple way. That's all. This is what you are getting. And this is your Z0, 0 sequence equivalent network. Now next, this was delta delta. Very important now is, I have talked about this. Let us see how many of you still remember this. So let me copy this one. Okay, copy, paste it here. Okay, now let us say the combination is, please listen to it properly. Combination is star connected reactance grounded. See here. This is Zn. And here it is star connected neutral grounded on this secondary side. So here I will be drawing it. This is star connected neutral grounded. Sorry, reactance grounded. So I am drawing the reactance here. Reactance is Zn. Other side. Yeah, roll number. Roll number 62, IFAM. 67, what is this? 62. Roll number 67, Irfan.
Yes, sir.
Can you tell me what's happening here? Now this is reactance grounded. Please remember.
सर जो सेकेंडरी साइड है वहाँ पे स्विच 2 विल बी क्लोज्ड, सीरीज स्विच विल
How
बी
come?
क्लोज्ड सर.
Switch 2 will be closed, लेकिन
सर जो
इसमें
प्राइमरी,
दोनों रिएक्टेंस ग्राउंडेड एक है, तो सेंटर में क्या आएगा?
सर मैंने
यू
लास्ट
आर नॉट
क्लास नहीं
क्लियर?
दी सर.
हाँ,
सर लास्ट क्लास मैंने नहीं दी रिएक्टेंस का, मुझे पता है.
आपकी यही प्रॉब्लम है. मंशा,
Yes, sir.
क्या होगा इसमें मंशा बेटा? चलो शाबाश. रिएक्टेंस ग्राउंडेड में क्या होता है? मैंने कल ही एक क्लास ली थी और वही मैंने पर्टिकुलरली रिएक्टेंस ग्राउंडेड के बारे में ही कहा था कि क्या आता है. शाबाश. रिएक्टेंस ग्राउंडेड में एक तो जेड नॉट आएगा, और भी आता है ना 3Zn. कल आपने किया था ना पिछले क्वेश्चन. एक जेड नॉट आता है, इसके साथ रिएक्टेंस ग्राउंडेड में यू हैव टू ऐड 3Zn. ओके. नाउ हियर प्राइमरी वाइंडिंग, रिएक्टेंस ग्राउंडिंग में तो पहले रिएक्टेंस, ये जीरो सीक्वेंस रिएक्टेंस में 3Zn ऐड हो जाता है. ये जो यहाँ Zn है वहां 3 बन जाता है. क्यों? क्योंकि न्यूट्रल, नाउ वी नो दैट करंट In is 3Ia0, so that's why the impedance becomes 3Zn. Second is, first primary side is star connected neutral grounded, so primary switch is different. This is again neutral grounded, although this is reactance grounded, but still it is neutral grounded. So this switch will be closed. This switch will be closed. Let me use this pen. This switch will be closed. Again, secondary side, it's neutral grounded star, and this switch will be also closed. But shunt switches will be opened. So if we want to draw it further, how we can draw it? We can draw it like this. मंशा,
Yes, sir.
आपको समझ आया कि नहीं?
Yes, sir.
मैंने कल दिखाया था यही, आपको यही केस 3Zn ऐड हो जाता है 0 सेकेंड्स में. So this
Yes,
was a very important point. So that's all. That finishes the combinations of various transformers. If you have been given the windings, how we can draw different types of windings. Okay? For a sequence networks, how we can draw it. So that's all for this topic. Okay. I think we have still 10 minutes. Okay, next topic is, please आप अपने somebody, इरफान रोल नंबर 67.
यस
रहने दो, आपकी आवाज आ रही है ना. यू क्लोज योर ऑडियो. नेक्स्ट इज सीक्वेंस नेटवर्क ऑफ ऑल्टरनेटर्स. So this is another important topic, sequence networks of alternators. Now here I will be, what we have a synchronous generator, and who has got the impedances are equal and the voltages are, EMFs are EA, EB, EC in the respective lines. Then we have a Zn, and that's a reactance from the neutral. And various voltages is R between the phase and the neutrals are VA, VB, and VC. And currents in the lines are IA, IB, and IC. So synchronous machine, when we have a synchronous machine, you know that synchronous machine generates balanced three-phase internal voltage. And we say that it's represented by the positive sequence set of the phasors. Positive sequence set of the phasors. So synchronous machine, we know. Synchronous machine generates balanced set of, balance, we can say balance three-phase internal voltage, and how we represent it, and is represented by a positive sequence set of phasors. That means we can represent the ABC EMF of the synchronous generator as 1 A square A into EA. Machine generates balanced three-phase internal voltage and is represented by the positive sequence set of phasors. So if we apply the KVL here, you can see the voltage VA in this loop between this phase and the neutral. Voltage VA can be written as, first you go here EA, okay, then move to this one EA, then this current here is ISZN, IAZS, okay, that will be minus. Here, this will be, if we are moving from here, okay, first sign is negative, minus IAZS, then positive EA, okay, then we move from current direction is here, so it will be positive here, negative here. So first here we are coming from here, it will be negative Zn IN, and then when we move from here, this voltage is positive for us, or this will be negative, plus minus will be here, but on the other side it will go as a positive. So here you can see, if we apply KVL to, I will show you the path. Path is like this. One I will show you, it's very simple. We have to come back to the same point. So how we can write the KVL? In this case KVL will start from here, plus minus F first, minus ZS IA, okay, this will be plus EA, and moving from here again it will be minus INZN, then moving from here to here, this is here positive, this is negative sign we take, minus VA will be equal to 0. So VA can be written as, VA will take on the other side, EA minus ZSIA minus ZNIN. So same equations we are going to write here. So applying the KVL in each phase, VA will be equal to EA minus ZSIA minus ZNIN. Similarly, VB can be written as EB minus ZSIB minus ZNIN. Similarly, VC can be written as EC minus ZSIC minus ZNIN. So we'll write this in the matrix form in the next class because we don't have much time now. So we'll be continuing with the same topic. Okay, Mansha?
Yes, sir.
Just a second. You can send me the log, beta, okay?
Okay.